two-step equations. All right, so yesterday we talked about rules for adding, subtracting, multiplying, dividing. So let's talk about steps here. Step one. The first thing you need to do is identify the term you're solving for. What has the variable in it? So sometimes you might need to actually circle so you can identify it, circle the term you're solving for. You don't have to actually do that, but it might help. You are solving for. Okay? You have to be able to identify it. And that includes the operation that's attached to it as well. Alright, step two. Move all the other terms across the equal sign. Alright, that's step two. Move all other terms across the equal sign. How do we do that? If you're moving the whole term, the only way you can move it is either adding or subtracting it. Okay, so that's rule number one from yesterday. Add or subtract anything. It can be a combination of things. You can even add and subtract a grouping. Okay? You can add and subtract 2x. You can add and subtract a quantity of x plus 8, as long as you're moving it as a group. Alright? Alright, step three. And this is multiplying and dividing. So when you get down to this step, you're usually, or you must be with your only term. The term that has the variable that you're solving for. You're now down to that one term. Now, the point is to get your coefficient to be positive 1. We talked about that. So how do we do that? You guys worked on that yesterday. Multiply or divide. Well, let's do this. Multiply by denominator or reciprocal. So we're multiplying by the denominator or multiplying by the reciprocal if it's a full fraction that's listed. Or we divide by the coefficient. When you do this, rule number 2 said you must do it to all terms. Now yesterday you only had one-step equations, so you were only doing it once on each side of the equal sign. But as we progress, there's going to be multiple terms listed. You must do it to all the terms. Alright, these 3 steps in yesterday's 2 rules are the most important thing you're going to learn in this class. You master these, you're not going to have any problems manipulating your equations to help you solve things later on. Okay? All sounds pretty easy. Let's check out a couple examples. We'll walk through this. Okay, example 1 is 2x plus 3 equals 5. Okay, we're going to start with the easy stuff and then move forward. We're going to go through the steps. Now I know that it seems obvious what to do here, but I wanted to use this to go through the steps to show you when you get more difficult, complex problems that you should rely on these steps to help get you through it. All right, this is one term here. That has the variable that I'm solving for. This is another term that's attached, plus 3. I need to move it to the other side of the equal sign by introducing a minus 3. Once on each side of the equal sign, rule number 1. Okay, so I'm left with 2x equal to 2. Now I'm ready for step 3. This is your homework from yesterday, one-step equation. It's attached by a coefficient, so let's divide off the 2. That becomes 1x, or x equals 1. Yes?
Well, why wouldn't you, leave 5 minus 3 over there, and then leave it like that, and then do the times 2, because then you would get, negative 1. You know, you would multiply 3 equals 6 first. Or is that the way to do it?
You'd have to multiply the 10 as well. But you're not multiplying, you divided it off the 2.
Oh yeah, you would have to divide the.
You'd have to take 5 divided by 2 minus 3 divided by 2. You still get the same answer. 2.5 minus 1.5 gives you 1. Okay?
Because you do it up to all other terms.
Yep, you do it to everything. All right. So what you're saying you're going to need here in a few sections to do it like that. Because you won't be able to take x or a minus b. You won't know what that is. So you'll have to leave it as a minus b. All right. So you're jumping ahead. That's good. 5 equals, this is example 2. 5 equals 4 minus 3x. And again, what Luke was talking about is really just following the steps, regardless of what you have up here. You're just moving things. It doesn't matter if it's an x, an a, a b, or 1, 2, or 3. You're just moving things, following the rules. All right, so again, remember the operation to the left of your coefficient is attached to that term. So that's the term I'm solving for, the minus 3x. I need to get rid of this positive 4. So we subtract 4, because 4 minus 4 is 0, right? Inverse property of addition. Okay? Am I going too fast? I know everybody in here should already know how to solve these. You've done this in previous years. Okay? But this is, we're going to go past this fairly soon. Alright, this is just a review to get to the new stuff. Alright, so this is 1 equals negative 3x. That minus now becomes a negative. So, again, I have a negative 3 times x. Step 3 is divide off the coefficient. I'm going to divide by a negative 3 because a negative divided by a negative is positive. Alright, so the answer is negative 1/3 equals x. Any questions so far? Alright, you have those notes for those steps. I'm going to be referring to those notes the rest of this year. Alright, anybody still need this? Okay. Example 3 is x over 4 plus 5 equals 2. Again, circle the term you're solving for. Get rid of your other term, so subtract 5. X over 4 equals 2 minus 5 is a negative 3. Correct? Alright. 4 is attached by division. You can either multiply by that or multiply by the reciprocal, which is still 4, to every term. So x equals negative 12. Alright, so stop me if I do something that doesn't make any sense to you. Example 4. How about this one? 2/3 x minus 1 equals 3. Again, identifying the term that has the variable in it. Get rid of your other term. Rule number 1, add it once on each side of the equal sign. Okay, so 2/3 x equals 4. Now what do I do? This is a new one. Yeah, multiply by the reciprocal of 3 over 2. Okay, so that's 6 over 6 or 1x. This becomes 12 over 2 over 6. Good? It's easy when I do it. Make sure you follow your steps. Example 5. 6 equals 2 minus 3/5 x. I'll give you guys a second to do this one. 20 seconds. 6 equals 2 minus 3/5 x. is 1/10?
Yeah.
Alright. This is the term you're solving for. Minus 3/5 x. And you get rid of the 2. The positive 2, you subtract it. So 4 equals
Oh, wait. Oh.
negative 3/5 x.
Wait, I can do it.
So now what do I do, Sophie?
You have to times 4 by the reciprocal of -3 over 5.
Yeah.
So it's -3.
Multiply by negative 5 over 3. Alright, so x is going to equal negative 20 over 3, which is negative 6 and 2/3.
You see, when I did that
That's
last
okay,
time,
you give an excuse.
instead of 4, I did 6.
Right here?
Yeah, like, because I still.
How'd you get 1/10?
I did 0.6 divided by 6. 0.6 is the 3/5, that's 0.6 in decimal form.
Oh, right here is 0.6.
Yeah.
So you divide by 0.6.
So it would have been negative 0.1. Because that would have been 0.6, and then you divide it by the 6, which I thought that was a 6, but it's really a 4, because you already subtracted 2 from the 6. You know what I'm saying?
Yeah. Example 6.
I'll get this one right.
3 equals negative 3 plus 2x. I'll try to make this a little easier to get. Alright, 20 seconds.
Oh, that's good.
Alright, everybody looks like they're doing a good job with their steps. I want you to start showing your work. Everybody hear me? Start showing your work. Sophie, what's your question? Who are you talking to?
He said, dang it, and I said, what?
Okay. We need to get rid of this negative 3, so we add 3. How many people did that? Alright. Good. 6 equals 2x. Now we divide off the coefficient. Alright, who got 3? Alright, you guys can be taught. That's wonderful.
Yay, I couldn't.
Alright, so that was example 6. Anybody still need that? I think everybody did it right. Okay. Find like terms. Okay? When you combine like terms, there's 2 things. You must have the same variables and the same exponents. Some of you really struggle with this. So, let me give you a quick example of this. Not very many in here struggle with this, there's a few. So if I say 2x plus 4x, the x's are the same letters, and the exponents are the same. Let's say it's 2x squared and 4x squared. And we'll kill 2 birds with 1 stone here. That is not 6x to the 4th. It's 6x squared. You have 2x squareds, you have 4x squareds. How many x squareds do you have? You have 6. The exponent doesn't change. It only changes when you're multiplying and dividing. Here you're just adding the things together. Okay? So they must be the same letters and must be the same exponents. So if I said 2ab plus 4abc, what would your answer be? Any?
2ab plus 4abc.
That's right. You can't put them together. They don't have exactly the same stuff. And it must be exactly the same. So this is 2ab plus 4abc. It's the same thing. It doesn't change. Alright, what about xy squared plus y squared x? Yes.
2y squared plus 2x.
Interesting. Okay, the second part to this I didn't tell you. When you have like terms that are the same variables and the same exponents, all you do is add or subtract their coefficients. What's this coefficient here? 1. What's the coefficient here?
Oh, 1.
Positive 1.
Okay.
Sorry.
Are these variables and exponents exactly the same?
Yeah.
Okay. Isn't x times y squared the same as y squared times x?
Yeah.
Yeah.
Why?
Because it doesn't.
Steph? Community property multiplication. That's why I put this up here. These are exactly the same. They're just in different order. Multiplication, you can do that. So this is 2, and we usually write it alphabetically. 2xy squared would be the answer. I'm glad we went over that. Example 7. 3 equals negative 5t plus 7t. This is really the first step in those steps I gave you. Okay, technically the first step is simplification. Is there anything you can simplify on the left side of the equal sign? You do that first. Is there anything you can simplify on the right side of the equal sign? You do that first. And then you really start those steps that we talked about at the beginning. Okay, if you need to distribute, you do that first. You don't always have to distribute. You can divide off that number that's in front of the parentheses if you wanted to. Okay. So, example 7, these two can go together. So 3 equals, what's negative 5? Remember? Same variable, same exponents. So, this is 2, 2. Exponents don't change when you're adding and subtracting. Don't do that. Alright, now you divide off the 2. T equals 3/2, or 1/2. Understand? Okay. One last thing, I'm going to add this to my notes. Example 8. Let's go 4 times the quantity x. Let's do minus. Minus 3 equals 16. 2 ways you can do this. You can distribute first, and that's kind of like what we're talking about here, this extra step simplifying before you get started. You can distribute and get 4x minus 12 equals 16, and now it's a 2-step equation. This is what we're solving for. We add 12. We get 4x equals 28. Divide off the 4. X equals 7. Right? Alright. Or, let me write this up here. Or you do this. How's the 4 attached to the parentheses?
Multiplication.
Multiplication. Can I divide by 4?
Yeah.
And here's the trick. This is where students make a mistake. Students do this. Don't write this down. They'll do this. No. Let's not do that. Unless you're going to distribute first. Okay? So really what I'd like to see is this. This is all one term here, isn't it?
Yeah.
Yeah.
Because the parentheses represents one thing. Doesn't matter how many things are inside the parentheses. It represents one thing until the parentheses are gone. Once the parentheses are gone, then you have 2 terms. All right, so here I'm going to divide this one term by 4. Now I'm left with x minus 3 equals 4. Add 3. X equals 7. I don't care how you do it. You can distribute first if you want. Follow your rules and your steps. Assignment. Page 144. 3 to 26, all mixed review evens.
Okay, why do you take videos if there's nobody missing?